Welcome back, Math 2. Today we're going to do some story problems where we're going to be incorporating that work that we have done previously to find the vertex, okay? So I want to remind you that the vertex, okay, to find x, I use negative b over 2 times a, excuse me, and then I will plug that back in to get y. That looks like an x. Okay, so I'm going to do this first, and then I'm going to plug it in, whatever that answer is, and that will give me y. Okay, so let's read our first story problem here and see if we can figure out what exactly they're asking. Okay. Jason jumped off of a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t, so h is height, t is time, negative 16t squared plus 16t plus 480. Okay? So by the way, what some of this means, the 480 is his starting height. Okay, and the 16 over here on the t is his starting velocity. So the force from when he jumped, okay? And the negative 16t, that just means that someone is falling or dropping. A lot of them will have negative 16 as that first number, okay? So remember, h is, we've got h and t here. T is going to be our x, representing our x. H is our y, okay? And the first question is, how long, or basically what amount of time, did it take for Jason to reach his maximum height? So this is basically just asking me for the first coordinate or the first part of my vertex, because it's asking me for x, and that's where I use the negative b over 2a. Okay. So my b was a 16, so I'm going to have negative 16 divided by 2 times a, which is also negative 16. So I really have negative 16 over negative 32, which if I divide that, either you can simplify it to 1/2, or you can use 0.5, but it took half of a second, or 0.5 seconds, for him to reach his maximum height. Okay, so if you picture, you're like, but he's jumping off of a cliff, like how is there a height at all? So if I picture, this is my cliff, here's Jason, okay? When he jumps, he's going to leap a little bit, okay? So there's going to be a little bit of a leap here. So this is where our parabola function comes in, okay? Question B is then, what was that highest point that Jason reached? So we're like, okay, here's his highest point. It took him half of a second to reach that. How high was he at that half a second? So I'm going to take 0.5 and plug it back into my equation here for t. So I'm going to have negative 16 times 0.5 squared plus 16 times 0.5 plus 480. Okay. Now, if you have just a normal calculator in front of you, you should be able to type all of this in exactly as you see it into your calculator at once. If you have your phone calculator, it's going to be a little bit more challenging. But basically, this should come down to negative 4 plus half times 16 is 8 plus 480. So negative 4 plus 8 plus 480 is 484. Okay, and these were in feet. Okay, so his maximum height was 484 feet, and that kind of makes sense. So if you take a little bit of a jump, the cliff, his starting height was 480. So after he jumps, he's going to be about 484 feet up in the air. So this is all part of our vertex. Okay. Let's try another question. All right. If a toy rocket is launched vertically upward from ground level, okay, I want to underline that real quick because I want to point something out in our equation later. With an initial velocity of 128 feet per second, then its height h after t seconds is given by the equation h of t equals negative 16t squared plus 128 feet if we neglect air resistance. Okay? All right, so let's point out a couple things in this equation. So the 128 feet per second, the velocity, that is right here. Ground level, if you think about it, is like 0, and that's why there is no number added on the end. Okay? I'm just going to copy this down here again a little bit bigger in case I need to move down. Okay, so basically if you need a picture, here's the ground, and a rocket's going to be launched, and then it's going to come back down to the ground. Okay? So question C is asking how long will it take the rocket to hit its maximum height? Okay, so again, my coordinates go like this, and I want to use negative b over 2a to figure out how long is it going to take for the rocket to reach that highest point up there. Excuse me. My b is 128, so I'm going to use negative 128 over 2 times a, which is negative 16. So I have negative 128 divided by negative 32. The negatives should cancel out. When I divide, I get 4. So this is in seconds, I believe. So it takes 4 seconds for this rocket to reach its maximum height. To reach its maximum height. And then they want to know how high is it. Okay, so we just found the time. Now we want to know how high is it when we get there. Okay. So let's try that out. So I'm going to plug 4 back in to my equation. So I'm going to have negative 16, and instead of t squared, I'm going to do 4 squared plus 128 times 4. Okay, so when you think about this, 4 squared is 16, and then I'm taking it times another negative 16, so that's negative 256 plus 512, which is going to give me 256. Was this feet or meters? Feet. Okay, so this is 256 feet in the air. That is the highest that this rocket is going to go.